What's going on? Got another video here for you. This one is on Taylor series for an applied calculus class. Alright, so let's get started. Shouldn't be too long of a video. Got 4 examples, really 3, but to work, so let's do it. So Taylor series, we have before I do that, in the last video we did Maclaurin series. So if we want to get accurate values of a function where the values of x are not close to 0, we might, if we use the Maclaurin expansion, we'd probably have to find a lot of terms. But now we have another kind of series, which is a Taylor series, that we can find a Taylor series for values that are not close to 0. And so what we have here, if we have f of x is equal to f of a plus f prime of a times x minus a plus f double prime of a times x minus a squared over 2 factorial plus, and then, I know I didn't write it, but the next term would be what? F triple prime of a times x minus a cubed over 3 factorial. And we would keep going. Okay? And you could do the 4th derivative or however many you got. Okay? So we want to so A is we're gonna find a Taylor series for an x that's close to a number a, and I'll explain that more when we get to not this example we're fixing to work, but the next one. All right, so here they want us to expand f of x equal e to the x in a Taylor series with a equal to 1. All right, so to do that, the first thing we need, well, it doesn't tell us how many terms to do. We'll go to, let's just go to the 3rd derivative. We'll find 4 terms. All right, so we have f of x is equal to e to the x. Now this one's pretty easy. This one's pretty easy because the derivative of e to the x is just e to the x. And then we have f triple prime of x is e to the x. And we need to evaluate each one, so we evaluate each one at 1, where a is. See, we need f of a, f prime of a, f double prime of a, and f triple prime of a. So that's just e to the 1, which is equal to e. And then f prime of 1, well, that's going to be, they're all going to be the same. That equals e, f double prime of 1 equals e, and f triple prime of 1 equals e. All right, and so now we just use this up here, okay? So we have e to the x is f of a, so f of 1, well, let's just write it out, f of 1 plus f prime of 1 times x minus 1, because a is 1, just plugging everything in, plus f double prime of 1 times x minus 1 squared over 2 factorial plus f triple prime of 1 times x minus 1 cubed over 3 factorial plus, and then it just continues on like that. And so now we have e to the x is f of 1, which is e, plus f prime of 1, which is e times x minus 1, plus f double prime of 1, which is e over, and this is 2 factorial is 2 times x minus 1 squared, plus f triple prime of 1, so that's e over 3 factorial. 3 factorial is 6 times x minus 1 cubed plus, and then it just continues on. And then what we can do here is we can write e to the x is, and what I'm going to do is I'm going to factor out a common factor of e. So that's 1 plus x minus 1 plus x minus 2, not 2, x minus 1 squared over 2 plus x minus 1 cubed over 6. Plus ... And then this would be your answer. Okay? All right, so let's go to the next problem. So we want to expand f of x equal the square root of x in powers of x minus 4. So basically what this means is expand f of x equal to the square root of x where a is equal to 4. That's all it's saying. Okay? So we have f of x is equal to the square root of x. So it doesn't tell us how many terms. So I'm going to go to the third derivative. I'm just going to do 4 terms. Okay? Now, you know, when it doesn't say how many terms, it's not necessary that it's 4 terms. It's whatever your teacher tells you. Okay? But I would imagine on a test, your teacher would tell you, expand it to this many terms. So everybody will do the same thing. All right, so what I'm going to do for the square root of x is I'm going to change that to x to the 1/2 because it's just going to be easier to take the derivative. So I've got f prime of x is 1/2 x to the negative 1/2. F double prime of x is negative 1/4 x to the negative 3/2, and f triple prime of x is equal to, 3/8 times x to the negative 5/2. And what we're going to do here is we're going to rewrite each of these derivatives. We're going to write it as 1 over 2x to the 1/2. I'm just bringing the x to the negative 1/2 to the denominator to make it a positive exponent. And this is going to be negative 1 over 4x to the 3/2. And this is going to be 3 over 8x to the 5/2. And then we have to evaluate each one of these at 4. And so f of 4, well, that's just the square root of 4, which is 2. F prime of 4, that's going to be 1 over 2 times 4 to the 1/2. Well, 4 to the 1/2 is 2, so that's going to be 1/4. And then f double prime of 4 is negative 1 over 4 times 4 to the 3/2. All right, so let me just do this one time. So 4 to the 3/2, that's the same thing as the square root of 4 cubed, okay? If we change it to radical form. So the square root of 4 is 2, 2 cubed is 8. So this is 8. So we got 8 times 4, that's negative 1 over 32. And then we have f triple prime of, well, I don't know why I put equals there. F triple prime of 4, well, that's 3 over 8 times 4 to the 5/2. And so that's 4 to the 5/2. That's the square root of 4 to the 5th. Square root of 4 is 2. 2 to the 5th is 32. So this is 32 times 8. That is going to be 3 over, what is that? Over 256. Okay. All right. So hopefully all that makes sense. All right. So let's see what we've got. We've got the square root of x is equal to, so let's just write it out. That's going to be f of 4 plus f prime of 4 times x minus 4 plus f double prime of 4 times x minus 4 squared over 2 factorial plus f triple prime of 4 times x minus 4 cubed over 3 factorial. And so we get the square root of x is, let's see, f of 4 is 2. So that's going to be 2 plus f prime of 4 is 1/4. So that's going to be 1/4 times x minus 4 plus, and then f double prime is negative 1 over 32. So that's going to be minus 1 over 32 over, see, f double prime of 4 is negative 1 over 32 divided by 2 factorial, which 2 factorial is 2 times x minus 4 squared plus f triple prime of 4, which is 3 over 256 over 3 factorial, which is 6 times x minus 4 cubed plus dot, dot, dot. And I forgot to put the plus dot, dot, dot there. And so now I get the square root of x is 2 plus 1/4 times x minus 4 minus, and 1 over 32 divided by 2. Now remember, 1 over 32 divided by 2, that's the same thing as 1 over 32 times a half. So that's 1 over 64 times x minus 4 squared plus, and then this 3 over 256 divided by 6, that's going to be plus, what is that, 1 over 512 times x minus 4 cubed plus dot, dot, dot. I believe that's right. Yep, that's it. All right. And so this is your answer. All right. So see, it's not that bad. All I'm doing is I'm plugging everything into here. That's all we're doing. Okay. All right. Now, where am I? Right here. Okay. So by using Taylor series, evaluate the square root of 4.5. All right. Now, let me explain something here before we do this problem. So it's wanting us to evaluate 4.5. So if I'm going to use a Taylor series, I'm going to use a Taylor series where a equals 4. So basically, I've already found the Taylor series, and so all I have to do now is take the 4.5. See, it's the square root. This is the square root of x. X is 4.5. So I just take the 4.5 and plug it in for x into this Taylor series. Now, what if it asked me to find the square root of, approximate the square root of 10.5? Well, then I would do this same thing here, but I would use a is equal to 10. All right. And, you know, if they ask you to find the square root of 4.1, well, you would use this. You would use a equal 4. Use something close to it. All right. And we'll get into that more when we do this problem, when they want us to approximate the value of sine 29. See, they don't tell us what a is here. So we'll talk about that. All right. So by using that, so let's just go ahead and copy this down real quick, and I'll pause the video while I do that. All right. So we've got the Taylor the Taylor series for the square root of x, where a is equal to 4. So I have the square root of 4.5. See, I'm replacing the x with 4.5. So that's going to be 2 plus 1/4 times 4.5 minus 4 minus 1 over 64 times 4.5 minus 4 squared plus 1 over 512 times, not x, times 4.5 minus 4 cubed plus dot, dot, dot. And so, and this right here is approximate. And so I get the square root of 4.5 is approximately, and then we just punch all that into our calculator, and we end up with 2.1213378917891. And so this is what we get for our approximation of square root of 4.5. Now, if we plug the square root of 4.5 into a calculator, let's see what we get. Square root 4.5. And the calculator gives us 2.121320344. And you can see, let's see, this matches, this matches 4 decimal places. So that's not too bad. And we just did, and we only did 4 terms in the Taylor series. And you can see how accurate we got. All right. All right. Here, calculate the approximate value of square root of 29 by using 3 terms of the appropriate Taylor expansion. So here we just need to go to the second derivative. All right, because the first 3 terms, see, that'll be 1, 2, 3. So we just go to the second derivative, and let's see how accurate it is. All right. So what I'm going to do here is I need to approximate sine of 29. So here I have f of x is equal to sine x, and I'm going to do this for a equals, what do you think? What do you think we're going to use a to be? It needs to be something close to 29, and we want it to be a value that we know. Well, don't we know the sine of 30 degrees is 1/2, right? We know the cosine of 30 degrees is square root of 3 over 2. Okay, so we're going to use a is equal to pi over 6. Okay, we're working in radians. When you plug these values, when you take, like for instance, when we evaluate, when we get our Taylor series and we've got to put 29 degrees in there, you have to plug it in there into the x values for radians, using radians. So in other words, when we get our Taylor series like this right here, we've got to plug in radian measure. We can't plug in degrees. So let's put everything in radians. All right, so I've got, let's see, f prime of x is equal to, well, that's cosine x, and f double prime x is equal to negative sine x. All right, so there we have it. And let me move this over a little bit. We've got a is equal to pi over 6. And so I have f of pi over 6 is equal to the sine of pi over 6, which is 1/2. And then I have f prime of pi over 6 is equal to cosine of pi over 6, which is square root of 3 over 2. And then f double prime of pi over 6 is negative sine of pi over 6, which is negative 1/2. All right. So now let's plug everything in. So I've got f of x is equal to, so that's going to be f. All I'm doing now is just writing down my formula and what I need. And then that's going to be plus f prime of pi over 6 times x minus pi over 6 plus f double prime of pi over 6 times x minus pi over 6 over 2 factorial plus ... All right. So there we have it. So now let's plug everything in. And so I'm going to get sine of x is f of pi over 6, which is 1/2, plus f prime of pi over 6, which is square root of 3 over 2. Wrote that backwards. Square root of 3 over 2 times x minus pi over 6. Let's see. Plus f double prime of pi over 6, which is negative 1/2. So that's going to be minus 1/2 over 2 factorial, which is 2. Whoop. And this should be squared. I left off my squared there. And that's going to be times x minus pi over 6 squared. And then the next one, I mean, it would be minus, because the derivative of negative sine is negative cosine, so we would have a minus there, and so on. All right, so we get sine x is equal to 1/2 plus square root of 3 over 2 times x minus pi over 6 minus, and all I'm rewriting this whole thing. To rewrite this is 1/2 divided by 2 is 1/4 times x minus pi over 6 squared. All right, so there we have it. Now we want to evaluate the sine of 29 degrees. So the sine of 29 degrees, now remember, this has to be in radians. So basically what we would do is we would put we need to put 29 degrees in radians. But what is 29 degrees in radians? It's 29 pi over 180. But what's another way I could rewrite, or what's another way I could write 30 degrees in radians? 29 degrees in radians. Isn't 29 degrees 30 degrees minus 1 degree? That's the same thing, right? So wouldn't that be pi over 6 minus, and 1 degree is pi over 180? Now you might wonder, why in the world are you writing it like that? Why are you doing pi over 6 minus pi over 180? Well, I'm going to show you. Watch this. So this is going to be 1/2 plus square root of 3 over 2 times. Now look, in the place of x, okay, I'm putting this in. So that's going to be pi over 6 minus pi over 180 minus this pi over 6. And see what that does is that just cancels out the pi over 6's. Okay, and then minus 1/4 times pi over 6 minus pi over 180 minus pi over 6 squared minus ... And so I get, and this is sine of 29 degrees is approximately, and I tell you what I should have done. Let me move this down to right there, and we have, let's see, let's write this as sine. And remember, instead of 29 degrees, we're using this. This is what we're plugging in. Okay, and then that equals, and then we just plug that in for x. Okay, I should have written that down, but I didn't. Oh well. All right, and so that's going to give us 1/2 plus square root of 3 over 2 times negative pi over 180 minus 1/4 times negative pi over 180 squared. All right, minus ... And so this is actually, when you punch that into your calculator, you get 0.4848088,509. And so that is our approximation. Okay. Now let's look and see what do we actually get when we plug that into a calculator. So if you punch in sine 29 degrees in the calculator, you get 0.4848096202. And so you can see, pretty accurate there, isn't it? Look at that. That matches up to 5 decimal places. And if we took this and rounded it, that would be a 9 there. But you can see how close we get to the actual answer using the Taylor series. And look, and this one we just did 3 terms, and you can see how accurate we got. All right, but that is all of this video. I hope it helped. Hope you learned something. But check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.